All right, ready for this week 5 craziness? I say this week 5 craziness because, well, while the week might not be crazy, this lab stuff is crazy. We are beginning probably one of the more difficult weeks of the entire semester for this lab. That is because this one kind of extends a nice long time. If you looked at the syllabus, you will notice that there is an energy consumption thing like 3 weeks in a row. That's because when I first started doing this lab, we had an actual lab manual, and I liked the energy consumption lab, but I thought it was just a bit too much to do in 1 week, so I broke it up to 3. So this takes a little bit of planning on your end. Gets a little confusing, but I'll explain. So, first off, you start off with your week 5. When you click on week 5 file, this talks you through a whole bunch of stuff. This right here where it says please read them, that's talking about the various documents. This week you will be doing energy consumption 1. But there is also this other thing that says energy consumption lab. This is a quiz. This will be open for the entirety of this lab. That means for part 1, 2, and 3, this will be open. It's a quiz. So you can go in there and you can answer some questions, but do not hit submit. You can save your answers. You can open it so you can write down the questions, work on it on your own, then come back, whatever. But this is for all 3 weeks. It's asking you specific questions for what you're doing each week. This is also starting your plant lab. The plants I highly recommend starting early because you're going to run into problems. Unless you are somebody who has always grown plants and you have never had one tiny issue with plants, you're going to have to start over at least once. Happens every single semester. The biggest issue people have with the plant lab is they will wait until the very last minute and then tell me they didn't have time. Yeah, you do. I give you a lot of time to do it by telling you about it now. So we're going to cover this. Now, my apologies at having these little bullet points all through it. These are a lot of hyperlinks, and without putting spacing in between, it gets very overwhelming very, very quickly. So I space it out. This is the video that you're currently watching. This is about the lab energy consumption part 1. We're going to talk about that in just a moment. This is the part that you're going to turn in. This is the 3-week quiz. Instructions about the plant lab. Data collection. Although this should not have a number 2, I'm going to fix that in a minute. So this is your data collection. This is going to look weird when you look at it through Blaze View, Brightspace, whatever. It's an Excel sheet, and for some reason Brightspace does not show the Excel sheet. So if you download it, you'll get a much better view, and I'll show you. This is written by a student because I, a couple of years ago, had as an extra credit thing that you could rewrite the labs. I use this one and my instructions so you can compare. Same lab, just different ways to look at it. I like to give you options because if how the student wrote it makes more sense to you, by all means use that. You still turn in the same stuff. Now this is the optional discussion for the energy consumption lab. Like I said, it takes over 3 weeks. I only have one optional board. And then this is for the plant lab discussion. Okay, now that's a lot of hyperlinks, so let's get started over here. So we have week 5. You will notice there's a lot of information here. What I want to show you real quick is Energy Consumption Lab. Here, part 1 is a PDF. This at the bottom is a Word document. It's the same thing, but since you have to turn in your documents to on Brightspace in your assignment, and it has to be one file, not a whole bunch of files, I include the Word document for people who would like that to make it easier, because you can download this onto your computer, you can type your answers in, save it, submit it, you're done. Yeah. So I'm going to show you how to do this in just a moment. This is the quiz. Note it says quiz. It's open the whole time. This is what you're going to do. You're going to be answering questions. Now, Plant Lab, my instructions. I'm going to go over this much. Okay? So when you go here, ta-da, it shows you that everything's going to close October 9th. So like I said, you have plenty of time to do this. You're going to need salt, plant seeds like radish seeds or anything that grows fast. Most people I know have used radish seeds and they do fine. 8 planting containers. You can use cups. You can use bowls. You can use old cans. You can use whatever you want, but each one has to be in their own individual space. Bottled water. Holy crap, you need to use bottled water. Normally I don't make people get bottled water, but it's because, not to be mean, if you live in the Valdosta area, that water's nasty. You don't know what all's in there, and it kind of affects your results. So if you use bottled water, you're removing any variables that you didn't know about. Potting soil like Miracle-Gro. Now, because of last semester, I have to specify, when I say Miracle-Gro, it's in a bag and it will say Miracle-Gro potting soil. The potting soil is the important part. I had a student who didn't understand that part and I was not clear enough, and this student bought Miracle-Gro plant food and tried to just grow it in the plant food. Not the same thing. It was interesting, made for a whole different kind of experiment, and it was kind of fun and entertaining, but you need to get potting soil. And it does not have to be Miracle-Gro as long as it is potting soil. Then 4 different bottles for you to mix up your saline solutions. Easy way to do this is if you buy a, I don't know, like a 6-pack of bottled water. You can take the bottled water, take 4 of them, pour that water into a bigger pitcher or something, and then use those 4 bottles to mix your saline solutions. Makes it easy. And then a ruler. You have to have some kind of ruler because you're going to measure these plants as they grow. When you measure the plant, it is from the bottom of the plant, i.e. the top of the soil, so the part that boop sprouts up, you place the ruler there and you're just measuring how tall it is. That's it. As it gets taller, it's easier to measure. When it just barely pokes through, you're not going to have a good measurement, but you just do the best you can. This is so funny because in the class, when I was recording for the class, a train went by. Hours later and yet another train is going by. So your 8 containers that you're building, that you're growing your plants in, you are going to put them about 3/4 full with the potting soil. You're going to label each of these. So 2 of them you're going to label C1 and C2. That means control 1, control 2. Then slightly saline, so SS1, SS2, moderately saline, MS1, MS2, and highly saline, HS1, HS2. Labeling this properly is extremely important because you need to know that you are getting the right information. So 1 bottle is control. This bottle is just your bottled water. That's it. So write control on this bottle of water. The slightly saline, you want this to have 2 cups of bottled water and 1/4 tablespoon of salt. So take 16 ounces of bottled water and mix in 1/4 tablespoon of salt. Mix it up, make sure it's dissolved. You can pour it back into a water bottle if you want to and write slightly saline on that bottle. Then moderately saline, 2 cups of bottled water and 1/2 tablespoon of salt. And then highly saline is again 2 cups of bottled water. And remember, cups means measuring cups, not just like a solo cup. So 2 cups, 16 ounces of water, and 1 entire tablespoon of salt. This is going to be very similar to seawater. So when you mix it, you stir it up. When it's dissolved, just taste it. If you're like, woo, and it tastes like the ocean, oh yeah, that's right. Now, for each of the containers, you're going to put 2 seeds in each container. So the C1, control 1, 2 seeds in it. Control 2, 2 seeds in it. Do this all the way. You're doing this because you're not sure if it's going to sprout. A lot of people ignore me on this part. They plant just 1 and then that seed doesn't work. If you put 2 seeds in each of these, you're more likely to get one that grows. Okay, here's another one. Put the seeds a bit under the soil. So just push it down, not far, just about this far. That's why it says to your first knuckle. This is what I mean, not all the way up to here. Just about here. You just want to make sure it's underneath there. Then, right here, pour the proper solution over each plant container. So if this is the control, you're putting just straight up pure bottled water. That's it. If it is the moderately saline, you put your MS. You pour that on there. Here's the other big kicker. Make sure the soil is damp. Do not just pour until it looks like a soup or mud. Do it until it stays just a little bit damp. If you have holes in the bottom of your container or cup, that will help you. That will save you a lot of trouble because every semester somebody drowns their poor plants. Here we go. Set all the plants by a window for light. It needs sunlight in order to grow. It's the whole photosynthesis thing. But here's the other part right here. If you have house pets, like cats, and I do like that because they're both sleeping over there and looking unbelievably adorable. Cats like to eat plants. So you'll want to find somewhere that they can't get. If you are putting it outside, just know squirrels love to help themselves to plants. So don't leave it somewhere where a squirrel can get them. Somewhere in your house where house pets are not going to get them is great. And here's another one. A lot of people have little kids. Letting your kids help with the lab is great. Making sure they know not to constantly water the plants is very important. Because every semester somebody has a kid who decides to help and they drown the plants. So talking to them and teaching it, that's a good thing. Making sure they understand the rules, very good. Keeping things out of reach of little hands and animals that want to eat them, also good. Now, mark when these plants sprout. So that means when something comes above the soil. So say that you planted them on Monday and then on Wednesday they sprout, then you say on day 2 they sprouted, that kind of thing. Each day in centimeters, measure from the soil to the top of the plant. Be very careful not to break the plant. That happens also a lot. And then put it on the Excel sheet or on your own table, but I'm going to show you the Excel sheet. You're going to do this for the entire week. Seriously, I missed this one right here. In the discussion board, you're going to have a discussion board. This date will be fixed. And you need to have the entire week's worth of measurements posted in the discussion board at the proper date. And you have to get information from at least 3 other classmates. You have to get the information from 3 other classmates because you need to talk about averages so you can compare your data to other people's data. Because again, above all else, this is a science class, and part of science is making sure it's not just your results, it's the average results. So there you go. Wrote up the stuff. I'm about to show you the table that can help. If you like it, use it. If not, don't. Your choice. And ask me questions. Seriously, try to get everything done as soon as you can. You will have to take pictures. Right here, I'm just letting you know. You will have to provide pictures of the lab to prove you actually did it. And again, measurements, very important. If you don't measure it properly, then it's going to mess the whole thing up. Now, let me show you. This is how Brightspace makes the table look. So it's not too bad. However, do I have it here? This is how it looks on Excel. So if you download it, this is what you're going to get, and then you can just type it in here. So say that on day 3 is when it sprouts, and my control 1 is 1/2 centimeter, my control 2 is a little under, and then say this one is 0.6, this one is 0.8, so on and so forth. You can totally just type it in here. When you get to the average height, this is for the class discussion, this is your average height of all of them. So this is what you will share, is this part. And then when you are figuring out the class average, this is what you use. So it would be averaging your control 1, your control 2, and at least 3 other people's control 1 and control 2, and you take the average of all of those, and that's what goes here. Yeah, so please ask if you have questions about this. So that is the plant lab. Now that brings me to the energy consumption. Energy consumption lab gets very confusing very quick, so I wanted to talk you through a little bit. Alrighty, so what you need: calculator, measuring tape, access to your bills, a scale, cup and bowl for containing water, and access to energy labels on household appliances. Other materials, this is what I use right here, is online stuff, or you can do this fancy stuff. And some of this is for part 1. I think the lumens calculator might be for something else. But anyway, first thing we're doing is the heat loss and gain through windows. Yes, it's a whole lot of words. I'm not going to read through all this. You can read through all this. But it's basically talking about how much energy you lose through windows. So I tried to highlight in yellow to help you find the super important parts. This is defining what happens. So the R value, when you see down here R value, this is telling you what the R value is. You need to know what type of window you have. The windows I have, these right here, these are single pane. They're not great. I would like to have them replaced, but I don't have money yet, and these are very, very old. So I have to do all my calculations with a single pane. So the R value for the United States is 0.9. If we were somewhere other than the US, these are the numbers we would use. We are using the US R value numbers because this is the US. Now these steps, these are what you're going to be answering. So why you needed a ruler or a measuring tape is for this. So choose a window nearby, measure the height and width of the glass surface. So that would be from the bottom to the top of this window and from side to side. The glass part, not including the metal part. Now what I have done is, let's see if I can open the right thing because I have so many things open. Nope, that's for other stuff I'm working on. Is it this one? Nope. That's for another thing I'm working on. I am doing way too much at once, aren't I? So, let's see. Dun, 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 dun. There it is. Okay. I have one where I was working it out so I can show you. La, 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 la. And just like that, I am thinking of the Smurfs. Okay, so here we go. I highlighted in yellow what I was doing. Now, number 1 said I had to pick the stuff. So I recorded 24 inches tall, 36 inches wide. That's obviously not these because these are taller than they are wide. When I did this calculation, it was for a window upstairs. And then use the calculation here in order to do it. So surface area equals the height times the width. So 24 times 36 over 144. So over 144. That gave me 6. So my surface area is 6 feet. Now, I use table 2 to determine the R value. Table 2 is this one right here. See, it says table 2, typical R values. So I am using 0.9. See, single pane. Using the thermostat, record the temperature inside the building. Okay, when I first did this, it was winter time. So inside my building was 66 degrees. Right now, it would be higher than that because it's summer. Using online resources, record the temperature outside. If you have a thermometer outside, you can do that too. I just do this because I don't have a thermometer outside, and so I just used that. So I did weather.com and just looked at what the general temperature was, or you can even just look at your phone. It doesn't matter. You'll see the temperature and then record it. So you can see when it was 66 degrees in my house, it happened to be 36 degrees outside. It was pretty cold. And then calculate the difference. So I took my big number, subtracted it by the smaller number, so it was a 30-degree difference in between. And then calculate the rate of heat transfer. Well, this means I'm going to take the heat loss over gain, or the heat loss or gain. For me, it was loss, BTU per hour, which is 30. And yeah, there we go. My surface area, I was already forgetting, my surface area times the difference. So 6, because that was my surface area, times 30, because that's what I put here, over 0.9, because that's my single pane window, and that gives me 200. Now, using the formula that I just used, I am supposed to figure it out for each different R value. So that means I do exactly the same thing, but I change this bottom number. So the 0.9, scrolling back up, I will do it with 0.9, then I will do it with 2.04, then 3.13, then 3.23, and then 5. This way I can compare all the different types of windows. Then calculate the difference if the surface area of your selected window was decreased by 50%. So that means instead of me having a 6, I would have had a 3. So then I record here. Yeah. And then calculate the difference if the inside temperature of my window was decreased by 5. So again, you're just adjusting your temperature and you're redoing your stuff. Then you use utility bills in order to figure out how much it tends to cost. So the unit cost. Here, you'll look here, I said for mine, I simply looked up the charges, so I didn't actually calculate. There's ways to calculate it, or I live in the city of Norcross, and I literally Googled city of Norcross, and then I looked at how they charge the electricity, and I just went by that. A lot easier to do that. Some people will say, well, I have no idea what it costs. Again, just look it up. It doesn't mean what is your bill. It means how do they charge. So even if you live in a dorm, which right now would be a very interesting thing, but even if you did live in a dorm, if you are in Douglas County, then you just simply look up whatever electric company services Douglas County and how they charge for electricity. Okay, then after you've calculated all that stuff, you will be filling out this table, table number 3. Notice I already told you this stuff. We already did the surface area of 6. This was reduced by 50%, and the surface area stayed the same. So this is the only one that changed. My inside temperature, I had to change this one because that was that one part it said about adjusting it by 5. My outside temperature remained the same all the way across. Temperature difference, other than when I changed the temperature, is the same. My R values, I already had the lowest R value window, and so that's all of those. But then you look at the highest R value, and then all those things you just calculated. This is telling you how much it's costing you in energy each year by these different choices. Okay, now, blah, blah, blah. Now you're going to record the mean monthly temperature for all 12 months of the year. That means take a look at what the average temperature. For me, I Googled monthly average temperature Norcross, Georgia. This all depends on where you're located to what you would look up. So you just look up your area and what the monthly average is. Now, in months with a mean temperature over 65 degrees, the difference will result in a negative number. Treat them as if they were positive because energy will still be flowing into the building and energy will still be used in air conditioning. So, even if you're getting negatives, just still use those numbers. Just drop the negative sign. After recording your data in columns 2 and 4, and I'm about to show it to you, use the calculator in order to calculate everything. And here's a big one. Remember that all months do not have the same number of hours, so some are going to be shorter. This is the table we're talking about. This is showing you an example. This is showing you the actuality. So here we go. These were the monthly averages for when I did this, I think in February of 2020. So here, the mean monthly temperature from what I looked up online, which I think they're not quite accurate. I cannot wait to see how it ends up for this year because that seems pretty darn low for me. Difference between mean monthly temperature and 65. So if it was 43, then it's 65 minus 43. Where it's higher at like 80, 65 minus 80. Notice again, I don't have a negative sign here. So this is the absolute value. So it's just what the difference is, period. All right, number of hours in a month. So you take this number times the number of hours in the month. These are different numbers because of how many days were in each of these months. And then this, the total degrees above 65 degrees. So you're gonna have all of these. And then finally, you add up the whole last column and put it here. Now, you're going to take this and multiply it by 6, which was the surface area of my window, and that gives me this number here. Then I will convert it to this proper one, which is to divide it by 3412, which is higher up in the instructions. It gives me this number. And then I multiply that by what my electric company charges. And so that gives me this number. Yeah. And that, I believe, is what we end up, scroll, scroll, scroll. That's what we're getting up for all of these things. Okay. I'm going to have to double check my calculations because I think something's a little off. But I'm going to have to take a look because I think this is really my main thing right there. Okay. Now, heating water. This is the last part for the lab for this week. It costs a lot of money to heat water, or a lot of energy to heat water. So it takes about 1 BTU of heat energy to increase the temperature of 1 pound of water by 1 degree. So here you're going to determine the cost associated with a leaking hot water faucet. This ends up being expensive. I happen to have a hot water faucet where I need to replace the faucet. We keep turning it and turning it and turning it more just to make it stop dripping. And I've mentioned before, I think that the house I live in is an older house. It's the house that my grandparents had, and I'm trying to slowly fix things. It costs a lot, so I haven't been able to fix a lot. It's just little by little because I don't have a lot of money. So it's bit by bit. I need to replace this faucet, and I would do it myself, but it's been here so long, I can't break it loose. I can't get the parts on the pipes to come loose, and I'm going to have to literally cut the pipes and replace them. And I'm not a plumber. I am good at changing things up, moving things around. I've replaced faucets in the past. I have never turned off the water by the street, the whole water main, and replaced all of it. And you can't even turn off the water to the sink. It's all that old and corroded. So I have to get the whole thing replaced. And they said when I asked somebody about it, it would be like $500 for a faucet. And that was me supplying the actual hardware. So it hasn't happened yet. So we just keep turning it tighter and tighter. Anyway, so I actually did this with that faucet. You're going to place, technically you're supposed to use a beaker if you're being super scientific. I just put a bowl, like a Tupperware bowl, plastic bowl, whatever. You put something underneath you water faucet. Should be your water faucet at home. Then you're going to turn on your water faucet to drip about 1 drop per second. Like seriously, play with it until you're like 1,000, 2, 1,000, 3, 1,000, because you don't want it to go super fast. And then set a timer for 15 minutes. After 15 minutes is done, then you weigh it. This can be done 2 different ways. I have, oh wow, it's raining. I have an actual kitchen scale. So I took the plastic container, I put it on the scale, and I wrote down how much it weighed. Then I did this, so then when I was done, I weighed it again and I subtracted what the container weighed. That's a good way to do it. Now, when I did it, in 15 minutes, I got 0.59 pounds of captured water. So now you're going to take that and multiply it by 35,040. So this is how many 15-minute periods there are in a year. So this will tell you how much water was wasted over the course of a year. Then you're going to calculate how many BTUs this would use. Then you're going to get to here, and so you're going to calculate using these formulas, depending on what it is you use, whether it's electricity or natural gas for your hot water. And then this is the data you want, and you record it in table 5, which is right here. So I calculated mine by electricity, which I realized was a mistake because my water heater is actually gas, but I'll just keep it as the electricity. BT used, pounds per year. This is the BTU needed. I take that and throw it in here for how much was used. Divided it by here to get my kWh. Multiply it by this, which is what I calculated earlier, or what I showed you earlier is what the electricity company is. And then that is the cost per year of wasted. And like I said, I made a mistake because mine is natural gas, not electricity for my water heater. And I really think I have a mistake in my calculations because I think my decimal should be over more, because I do not think it costs $4,000 for the hot water. Yeah, it's not going to be that much, but it could very easily be 400. So I think my calculations are slightly off, and that's okay. That's the other part I want to point out is sometimes your calculations might be off. That's okay. I understand. I just want you to do your best. So you'll see all the stuff I talked about right here in the file for you. So I think that's about it. Yeah, that's pretty much it. It's a lot of information, like I said, so feel free to look over it, and if you're not sure, email me, ask me. Make sure to email me because, again, I'm faster at responding to emails. It's very time consuming, but you really can do it in one day if you want to. Biggest thing is to start prepping for your plants. Yeah, I think that's about it. So, obviously when it rains, it totally distracts me more so than normal. I'm like, ooh, look, it's so pretty. But it's been a while since it's rained, so I'm very happy. Okay, so Let me know if you have questions. Shoot me a message, email me, and good luck. And don't wait till the very last minute. Please do not wait for the very last minute. All right. Good luck.